Can you, okay, is everything, I can try pulling it up on my laptop because I have it on there as well, the students' work.
Okay.
Okay. Okay, I should be good to go now.
Okay, great. So you have the permission to record. Once we're done with the meeting, the recording will automatically be saved to your computer in a Zoom folder as an MP4 file. So did you have any final questions?
Nope, I'm good to go.
All right, as soon as you see the students, the simulation will begin. Good luck. And remember, this is a training simulation, so it's a great opportunity to take risks and stretch yourself. I'll see you in a bit.
Hi.
Hi, guys. You guys
Oh,
ready
your
to
hair
do
is
some
really
math today?
pretty. Your hair is really pretty.
Oh, thank you. Okay, so what was the problem we had last week? Can anyone tell me?
Yes.
What was the problem last week?
Oh, we were doing division. It was 15 divided by 1,080.
Yeah, so who wants to share the first step they took when solving this problem?
Okay, so I can share.
Okay, awesome.
So what I did was, let me look. So I did a lot of it in my head, the first part anyway, and I knew like 15 times 100 would be 1,500, and that was way too much. So then I thought about 15 times 50, which was way too low. So then I picked something in the middle, and 75 would be in the middle, but that was easier. It was easier to multiply by 70 with a 0 with the ones in place, and then that gave me 1050. Then I just needed 30. So that's what I did.
Yeah, that's awesome. So I like how you used 70 there. You used an easier number to make the problem something you were more comfortable with. What other numbers did people use? Did anyone do something slightly different?
Oh, I did something kind of different.
Yeah, Carlos, let's look at yours.
Okay. So what I did was I guessed and started with 15 times 10, which was way too low. But I like kind of kept it on the side and tried again, and then I tried multiplying by 20 and then 30. And then after that, I only needed 180, so then I went back to 10 because I already knew that was it was 150.
Yeah,
And
so
then that got me to 1050.
let's take a moment and look at yours. So I see how you did 15 times 10 and then you got 150 and you kept track of your addition work in that far right side right there. So all of your multiplication work is correct. But really quick, I want you to check, what is 15 times 62?
You want me to write it down?
Yeah, just think really quick. You can write it down and just solve it out. What is 15 times 62?
Okay.
That's what you got as your answer there.
Okay, when I double check that, 15 times 62. Hold on.
Why don't all of you guys try that real quick?
Oh, it's 90. It's 90.
Yeah, so it's not quite a big enough number, is it? We were looking for 1,080. But so all of your work up until that 62 was correct. So why don't we check your 10 plus 20 plus 30 plus 10 plus 2? What does that equal?
Okay. Let me do it. Let me write that down. hold on. Let me add it up. 2. Oh, oh. I forgot I did, yeah, I see what, I did 62 instead of 72.
Yeah, so you did all of your work was right. Everything was fantastic. Just right there at the very end, you made a silly, simple mistake, which is why it's
Yeah.
awesome to go back and check your work. Because then you can
Yeah, and I
see
see
those
like,
things.
yeah, because like the way that I wrote, when I wrote all the numbers down, the way that I wrote is like the way the 1 is on that bottom 10, I missed it. I missed it.
Yeah. So so we figured out when we checked our work that the correct answer is 72. Did anyone else get 72 as their answer and want to share how they found it with the class?
I got 72.
You did, Mina?
Mhm.
How did you find 72 as your answer?
Okay, so what I did was I tried to narrow in on the right numbers to be multiplied. And so I tried 90, but that was too high. So I subtracted 1080 from 1350 and got 270. And then that rounds up to 300, which is 15 times 20. So then I knew to try 70 instead of 90.
Yeah, so do the rest of you guys understand Mina's thought there? How she got to 70?
I I I totally don't understand. That was so confusing to me. I don't know.
Yeah, so she did something really interesting. She did some rounding in her work. So when she got 90 as her first attempt, she found her answer was way too big, wasn't it? She was
Yeah.
270 over, which she rounded to about 300. Doesn't that sound like a pretty good rounding? So how many times does
Yes.
15 go into 300?
20.
Yeah, 20 times. So she figured that 90 was 20 too big and used that to get 70 in her
Oh.
work. So Mina, why did you circle that 70 in the 2 there? And what made you decide to place them there?
Well, what I did was when I had the 70, when I realized that that number was the one that worked, and then I knew that, I had 30 left, and 15 times 2 is 30, I put that over there too, and I circled them to remind me to add them together.
Yeah, so if we look over at Emily's work now, Emily, I see you did the same thing, but you had some different numbers. Do you want to share how you came at your numbers?
Okay. Well, what I did, I picked 60 to multiply by 15 because I knew it wouldn't go over. And 15 times 60 is 900. So then I subtracted 900 from 1080 and I got 180 left. And I know that 180 minutes equals, this was funny how I figured this out. I know that 180 minutes are 3 hours and that there are 4 15-minute chunks in 1 hour. So then 12 15-minute chunks are in 3 hours.
Yeah,
So
that's
that's
really
how I did it.
great. Do you guys follow what Emily did there? Can anyone else? Can you guys see that too? Thinking about it as
Oh,
time.
that sounds huge, like a lot. Like I get it. Like I know about 4 15-minute chunks are in an hour. In an hour. I do know
Mhm.
that. But 60 is just such a big number to try to figure it out.
Yeah,
I
well,
think.
that's okay. Just use numbers that you're comfortable with and find little tricks that work for you like Emily did. So, Will, are you the
Okay.
only one who we haven't looked at yet?
I don't know. I guess.
Yeah, so do you want to share? It seems like you were able to do a lot of your work in your head.
Hmm. Well, I tried to guess. I tried to guess first, and so what I did was I guess what number might get me close to 1080. And first I did 50, and that brought me to 750. And I knew I needed half of that, so I tried 20, which is 300, because 20 is easier than 25. I know 25 is half of 50, but I did 20 instead. And then I added those together, and then was only 30 away. And so then that was easy because everyone knows 15 times 2 is 30. So then I just added 15 plus 20 plus 2, and I got my answer.
Yeah.
50 plus 20 plus 2.
Yeah, great job. You guys all did some really good work. I see a few of you guys did that. When you were choosing your numbers, you would have a number, but you wouldn't like the number, like it'd be 75. So you would change it to 70 or 25 and change it to 20. Do you guys find it's easier to multiply with numbers that end in 0 rather than 5?
I do.
Yeah, so that's a really good strategy, is to pick numbers like that that are easier for you to work with so that you're more comfortable when solving the problem. So
Yeah,
now,
and it worked for me too. It worked for me too because since like I was thinking 75, but that number seemed too hard. So instead, what I did was I did 70, and I'm so glad I did because the answer was 72, so 75 was still too high.
yeah. So now we're going to move on and look at some of your other classmates' work. Can everyone see Max and Leah's problems? So what's something that Leah did? We talked about it a little bit before that none of you guys did. Why don't you turn and talk to the person next to you and look at Leah's problem and try to figure out something she did that no one else tried.
When I look at Leah's problems, it seems like she did a lot of stuff in her head like I do, and she tried to use a small number.
Well, I think Leah did something more similar to like what I did. When she did the 7, well, she started with an 8.
Oh, why would she start with an 8? It's nowhere near 1,080.
Well, no, but she started with 8 because she was looking at 108, not 1,000.
Okay, I'll give you guys a few more minutes to wrap up your thoughts.
Yes, I did that. She did hers. I did mine more like Max. I feel like Max, he started off with 50, and that was like similar to me, I think, because when I look at mine,
Okay, has anyone thought of anything different that Leah did? What did you guys notice?
Well, when I look at Leah's was more similar to like Emily's and Mina's.
Yeah, what was similar that you were noticing?
Oh no, sorry, that's Max. Leah's was more similar to mine because she used a small number. She didn't do a big number like how Emily did 60 as her number, but I did a small number, and so did Leah. Leah did a small number.
Yeah.
I did 10.
Yeah, so instead of seeing how many times 15 went into 1,080, she started with seeing how many times 15 went into 108 and just ignored that 0 for later. So you could kind of just cover the 0 up with your thumb if you had it on the paper in front of you. So the first thing she did was 15 times 8, if you look at her work, which she got 120 for that, but she was looking for 108. So that was too big, wasn't it? So what number
Yeah.
did she try next?
Yeah. And she did 7.
Yeah, so that she got 105, which is less than 108, right?
All right, welcome back, Aaron. It goes by fast.
Yeah.
Thank you for participating in that simulation. For the next 5 minutes, we'll reflect on that experience. So, how are
Okay.
you feeling after that simulation?
Good.
Great, great. How do you think the kids, the students, are feeling?
I mean, we didn't get to finish. They're probably confused at the moment. But they seem
Well, I
to
think.
um they seem to do a good job of like explaining their own work. But I think they kind of got a little confused when looking at someone else's work, just because they all had different
Mhm,
mindsets going into the problem.
mhm. Yeah, I agree. I agree. And, ending the simulation, they might be slightly confused, but probably no more confused than, say, if a fire alarm, if they have a fire drill or something in the middle of class, so
Yeah.
they have to drop everything and leave. So they can pick up right where they left off. Um, yeah, so in relation to the outcome, which strategies or best practices did you use well?
I was trying really hard to like let them facilitate the conversation more, um,
Hmm.
rather than me just talk at them. I wanted them to like explain their reasoning so that I, as the teacher, could understand it. Um, like
Sure.
which student was it? Let me pull this up. Like how Emily was talking about the time, and how she
Hmm.
solved the problem, like thinking about it in terms of 15 minutes going into an hour, and that's why she used 60. If I wouldn't have like given her that opportunity to share, I would have never known that that was her thought process. And even like
Yeah,
myself,
yeah.
um, thinking about it in terms of time, that hadn't even like occurred to me. So I'm sure it didn't occur to a
Hmm.
lot of other students too. Um,
Hmm.
so I was really trying just to like have them explain their reasoning for me to learn about their thought process rather than me just explain at them.
Got it. Yeah, and I think that that was effective. One, it gets them all engaged. So that's definitely what the goal is. And they can. It's a way that they can teach one another. And even it was a learning opportunity for you, like you said, you didn't even think about time. And then what you did great after that was piggybacking off of that and then asking someone else, how they felt about that and the idea of time. That's when Carlos said that he was completely confused by that concept. Um, so I think that was a very fun moment. Yeah. Um, what modifications did you use to support all of your students?
I was kind of trying to like build momentum off like one another's problems. And so like Carlos, how he got the wrong answer, I didn't want him to feel singled out, which is why I went into the conversation of checking our work. Um,
Yeah.
what was I saying? Checking work. Um, emphasizing the fact that like his multiplication work was right. Having him realize on his own that there was a mistake made and then solve
Hmm.
it rather than being like telling him it's wrong, go fix it, having him figuring out
Yeah.
on his own and solve it so he
Yeah.
feels more like he accomplished something rather than he messed up.
Hmm.
I try to like connect ideas between like Emily and Mina, how they both circled like the 17, the 2, and the 16, the 12.
Sure.
I would have liked to have like some sort of like more interactive thing I could do with them, but like obviously virtual. It's hard to use physical manipulatives.
Yeah. Well, and it's so interesting that unfortunately with the pandemic going on, that's just a lot of ways that teachers are connecting with their students is virtual.
Yeah.
So this is, I guess the silver lining of this experience for you
It's good
is that you're
practice.
getting to, yeah, for what the world is going through, at least right now. Um, all right, great. Well, if you had a chance to do this again, what do you think you could improve upon?
Time management. Again, I didn't have enough time to get through Leah and Max's work.
Sure.
There was another spot. I already can't remember what it was when I felt caught off guard when a student said something, but I already forgot what it was.
Well,
but I guess just anticipate the unknown more.
Yeah, I would say anticipate the unknown, stay engaged, it sounds like.
Yeah.
You know, uh, I'm gonna guess, and I could be totally wrong. Was it when JLo was explaining that when you were talking about 55 or 75 using numbers that end with 0 if it's easier, and then she mentioned she wanted to use 75, but she's glad she didn't because 72 was actually the right number. Could it be that, perhaps?
It might have been. It was something with like the 0 to 5. I don't know.
I'm guessing that it was that only because she sort of interrupted you
Yeah.
when you were moving to the next step. So maybe if you weren't prepared for that, you know, and of course she's doing it because she's excited, not as a disciplinary issue. But she was excited to tell the story about how 75. She's glad she didn't use 75, even though that's
It
what
would
she
have been
wanted
too
to
big. Yeah.
Yeah, and she didn't know that. But 70 worked for her. Okay, well, what's one thing you're taking away from this experience that you'll use the next time you face a similar one in real life?
Probably just like you're never gonna. You can look at a student's work on a piece of paper, but you don't really know what was going on in their head. Like, what I had planned to talk about with Emily was completely different than what I actually did because she brought up that time thing. And I actually liked what she brought up better. I just wasn't expecting it.
Yeah. Great. Well, they say kids say the darndest things. So you'll definitely have your work cut out for you for that. So, okay, great. All right, well, that concludes the simulation. You can go ahead and stop recording now. And just a reminder, the video will be available